Okay, so just the basics background of trig first. This just goes through all of the basic trig functions. You should have at least been familiar with the three on the left. You've probably heard the word SOHCAHTOA, or the acronym SOHCAHTOA, which is just that the sine value of any angle is the opposite over the hypotenuse when you're looking at a right triangle. It is important that all of these are based off of your right triangle rules. These are all said right here. We've got right triangles, and this specific one that they're looking at here is based inside of a circle, so that the hypotenuse here is going to be the radius of our circle. The x and the y values would be based on the point here. The distance here would be x, and the distance here would be y at the point x, y. So that's kind of what they're looking at when they developed all of theirs. So they said the sine of theta was y over r, which is the opposite over the hypotenuse. So when you're looking at your angle, a couple things to keep in mind: that the hypotenuse is always opposite the right triangle, or the right angle. So as they start spinning these things around, because they won't always be perfectly easy to see, as they start spinning your triangles around, remember that the hypotenuse is always opposite that of the right angle. And then when you're looking at an angle, the side that is not touching the angle, the side being made up essentially by the angle itself, is going to be your opposite, and the side that is one of the legs part of the angle is going to be your adjacent. And then, of course, the hypotenuse is always the one across from the right angle. So sine is opposite over hypotenuse. Cosine is adjacent over the hypotenuse. So here it'd be x over r. The tangent of theta is going to be the opposite over the adjacent, so y over x. And then these are just the reciprocals of those. So the cosecant of theta is going to be r over y, or hypotenuse over the opposite, because some of our identities here is that the cosecant of theta is the same thing as 1 over the sine of theta, which will kind of come into play later, but that's going to be 1 over the sine of theta. And then our secant of theta here is going to be hypotenuse over adjacent, which is just secant of theta is 1 over the cosine of theta. And then the cotangent of theta is, instead of being, so the tangent is the opposite over adjacent, cotangent would be adjacent over opposite, which is going to be the same thing as the 1 over the tangent of theta. Okay, so those are our basic trig functions, the 6 basic trig functions. Again, a lot of people have heard SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So when we're looking at these particular things here, if you consider the fact that the Pythagorean theorem here would give us that x squared plus y squared would equal to r squared in this particular triangle, if we place our triangle inside what we call a unit circle, so the unit circle just has a radius of 1. Okay, that's what a unit circle is. It's literally 1 unit. So its radius is going to be 1. So if we place it inside a unit circle and make that r value 1, then what we end up with is x squared plus y squared is equal to 1. Well, if you look right here, since the cosine of theta is equal to x over r, if I were to just take this and solve for x, well, I would multiply both sides by r. So that would mean x is equal to r times the cosine of theta. Okay, and then similarly here, same sort of concept there. If I have that the sine of theta is equal to y over r, just based on this up here and the fact that it's opposite over hypotenuse, just by definition of a sine function, then that would mean that r sine of theta is equal to y. So now going back to the same idea, if we put this thing in the unit circle, which is a circle of radius 1, okay, same thing I wrote up here. That's an important concept you'll see over and over. A unit circle has a radius of 1. Well, when you put an r value of 1 there, then you have that x is just the cosine of theta and y is just the sine of theta within the unit circle. So then, looking at that, when x squared plus y squared is 1, I can replace the x value with the cosine So then I would get the cosine squared of theta plus the sine squared of theta, because y is equal to the sine of theta. So I get sine squared of theta is all equal to 1. All of that is the same thing as what we have here on the next page, which is called the Pythagorean identity, which is cosine squared plus sine squared of theta equals 1. This is something that is going to show up time and time and time again. So this is one of them that is a big one. It starts off at the very beginning of the packet because it shows up so often. So this is one that you just really need to commit to memory, or be able to compute it from our Pythagorean theorem. So if you can just get there from Pythagorean theorem, that's even better, because then you don't have to memorize extra things. I personally just know that it's Pythagorean, and I know x is cosine and y is sine. So it's a pretty easy one to create and or memorize. It does note this down here, and this is very important as we move through this unit. It won't show up till a little later, but the sine squared of theta is the same thing as the sine of theta squared. It is not the same thing as the sine of theta squared. So here, sine squared of theta and sine of theta squared would be sine of theta times the sine of theta, which makes the sine squared of theta or the sine of theta squared. These two things, this notation is the same thing. Okay, this right here, sine of theta squared, means the sine of theta times theta. Okay, so those are two very, very different things and very, very different values. So just keep that in mind. Please do not write sine of theta squared, because this does not mean the same thing as this. If you are squaring the entire term, if I have the sine of theta and I want to square the whole thing, okay, then it's either written out there or it's written behind the sign. So just keep that in mind. They do use different notations specifically so that we know the difference between squaring the theta value versus squaring the sine of theta value, because those are different values. Okay, so then into homework 4.0, looking at our triangle. So our basic objective here, they want us to find all of the different values. So when they give us the sides, we just need to find the third side. So regardless of whether I'm finding the hypotenuse or whatever, if I have two sides, I can always find the third side because it's a right triangle. So 6 squared plus 12 squared equals c squared, which is just going to be this guy here. And so 36 plus 144 is c squared, which is 180 is c squared. So c is going to be 326 square root of 3, right? 36, that's not right, 1224. Let me just break it down. Goodness gracious. 9 and 20, 4 and 5. There we go. So square root of 5, that's where I messed up. So square root of 9 is 3, square root of 4 is 2, 3 times 2 does make 6, and then the 5 would be left over. Okay, so 6 square root of 5 would be that side. So then going through and just finding all of those things once we're there. So the sine of A is opposite over hypotenuse, so that would be 12 over 6 square root of 5, which would reduce down to 2 over the square root of 5. Now, on this particular worksheet, they don't rationalize, but typically your answers are rationalized, especially when we get to the unit circle. So rationalizing just means to multiply by that radical on the bottom, so that you no longer have a radical on the bottom. 2 square root of 5 over 5. That's all you're really doing. So just rationalizing, and then sometimes we have to undo rationalizing when we start doing other things. But that's essentially what you're doing. So then you're just going through each one of them. Cosine of A is adjacent over the hypotenuse, so 6 over 6 square root of 5, which is 1 over the square root of 5, which would just be the square root of 5 over 5. And you just work your way through all of them. Tangent of A is opposite over adjacent, which is 2. And then doing secant, cosecant, and all of those, you just kind of take that same stuff and go backwards. So the secant of A is the same as 1 over the cosine of A. So you just take your cosine of A and flip it over. So that would be 1 over the square root of 5, which is just square root of 5. And I didn't use this one just because if I did, then I'd end up with a radical back on bottom, and I'd have to rationalize again and then simplify again. So I just went back to before I rationalized it. So that would be the secant. Your cosecant of A is just 1 over the sine of A. Okay, so 1 over the sine of A, again, I'm going to go with the, before I rationalized, would be the square root of 5 over 2. And then the cotangent of A is just the 1 over 2. Super simple when you already have once you already have like the sine, cosine, and tangent, because these are just reciprocals. So you just flip them over, not a big deal. If they give you something like this, well, you make your own triangle. So we know it's adjacent over hypotenuse, so that would make adjacent, that would make a hypotenuse. And then you would just be looking to figure out what this extra side was. Same process though. 24 squared plus b squared is equal to 25 squared. Save us some time and use a calculator here. Which would be b is equal to plus or minus 7, but we don't need negatives when we're talking about the length of a side. So we would get 7 there. And then you just go through that same whole process. I'm not going to do that on the video, but you basically just go through. This is my A. This is my right triangle, adjacent hypotenuse, and now I have my opposite, and you can list out all of those values. When you get here, and you're looking for stuff like this, so remember that the sum of the triangles, sum of the angles of a triangle should equal 180 degrees. So hopefully we can remember that from geometry. So I've already got, this is 90, so this is going to be 90 minus 74, or just 16 degrees. Okay, so you've got 16 degrees right there. And then once we know that, we can go ahead and do all of the rest of the things. So again, they want us to solve for the unknown side. So doing the unknown side, first of all, this is my hypotenuse, because this is all spun sideways, right? So across from the 90, this would make my hypotenuse. So when I'm setting up my trig ratios, make sure this is your hypotenuse. So if I'm using this angle right here, okay, so if I wanted to find A, well, A would be the adjacent, okay, and then 13 would be the opposite. So opposite and adjacent is what I have. So I would use the tangent, because that has opposite and adjacent. So the tangent of 74 degrees is opposite over adjacent. And then I can just solve for A. So that would be 13 over the tangent of 74, which I would then just toss in a calculator and get an approximation for. When you do your calculator stuff, do make sure you're in the correct mode. So your mode has both radians and degrees. We will get into radians in this unit after a few lessons, but right now we're in degrees. So make sure you're in degrees or all your answers will come out incorrect. So 13 tangent of 74. Helps if I do the division sign. 13 divided by the tangent of 7. Ooh. Which is approximately 3.728. And you can always check that later on. So then I want to find this one right here. Try to avoid using anything that you have used as an approximation as much as possible. So like when I do find C, I now have the opposite and the hypotenuse. So opposite and hypotenuse would be the sine. So I've got the sine of 74 is equal to the opposite is 13. Hypotenuse we don't know. So C is going to be 13 over the sine of 74. Okay, so try not to use like A to find C, because this is an approximated value. So here's my exact value, 13 over the sine of 74. And then I go from there and I get approximately 13.524. Okay, so that's the general idea behind those. Now, 6 and 8 here, which both of them, neither of them have an angle to work with, and they haven't really talked about how to get there. So I'll do one similar to that, just so that I'm not doing the ones that you are actually doing. So let's say we've got 3 and 5 as my values there, and I don't know this guy. Okay, so if I'm doing this, so again, I can always find this. So a squared plus 3 squared equals 5 squared equals 9, plus 9 equals 25. A squared is equal to 16, which means that A is equal to 4. Okay, so we've got A is equal to 4. Okay, so we've got the sides now. Now to figure out what your angles are, so since we don't have a single angle to work with other than our 90, okay, and you can't really use the 90, you can only really do this stuff with the other side. So when I go to set it up here, I can use any of those things, doesn't really matter. So let's say I do let's say 3 and 5 were my givens, so I had adjacent and hypotenuse. So I would do the cosine of A is equal to the adjacent over the hypotenuse. This is not a special right triangle, which we'll learn about in the next section. So instead, we use what we call the arc sine. So this is like the inverse operation. So if we use the arc cosine of both sides, then what this does, the arc cosine of a cosine will essentially cancel each other out and tell me what the angle is going to be. Okay, so by doing that, it's saying what angle would produce a cosine value of 3/5. So that's what it's doing. And again, this is a calculator thing, which is right here underneath the cosine. Oops, sorry, right there underneath the cosine. So I'd hit second arc cosine of 3/5, which would be approximately 53.13 degrees. And you could do the same thing with the B. So B, if I did 3, that would be opposite in hypotenuse. So the sine of B is going to be 3/5. Okay, so then doing that, so then the arc sine of both sides which means that B should be approximately 36.87, which notice that the two of them together do make 90, so I could have just done a subtraction, but I was just kind of showing you the different ways. But this is how you go about figuring out an angle when you don't have an angle to work with. Okay? And then, let's see what else. Okay, most of these things just come into creating a picture, not a big deal. But I do want to talk about angle of elevation and what that means and the angle of depression. So if I am, let's just say I'm sitting in a building, this has nothing to do with this one that I'm on. Here, let me just use the board itself. But just so you kind of have an idea of what it is, if I'm like, say, sitting in a window of a building and I'm looking up and it says the angle of elevation, well, if you were to draw a straight line to whatever you're looking at, let's just say that I'm looking at a tower or something like that. If I were to draw a straight line, then from there, the angle of elevation from the straight line from where I'm at to the top of the building or whatever, but this would be your angle of elevation. And then if I was looking straight at the building, and then I took my eyes and I looked down, this right here would be my angle of depression. Okay, so that's what it means. So when we talk about the angle of elevation, if you just take like your eyesight, because there's a bunch of them where it's like, you know, you're standing there and you look at the top of the thing and then you look at the bottom of the thing. So if you were to draw a straight line, the going up here is the elevation and the going down here is the depression. Okay, so angle of elevation and angle of depression. That's what that thing is looking at. So angle of elevation, and then straight line, and then down from there would be angle of depression. Okay, so that's what they're talking about there. And once you get down here to like 14, 15, you do want to start using, you're going to have to start using sometimes like a system of equations essentially. So let me just do one of those for you. So there's an antenna on the top of a building from a location 500 feet away. So we've got this 500 feet away from the base of the building. The angle of elevation to the top is 40. All right, so we've got this building. When I'm looking at the top of it from 500 feet away, the angle of the building is measured to be, the angle of elevation is measured to be 40 degrees. Okay, and then from the same location, the angle of elevation to the top of the antenna is measured to be 43. So on top of this building, there's this little antenna here. And the angle of elevation to the top of the antenna, so this whole angle is 43. So as many times as we can, what we want to try to do is we want to try to set these things up so that there's only one variable if possible. So like here, looking at this triangle here, so here's my right angle. This side right here, let's just say we call this thing, let's just call it X. Actually, we're going to call this antenna height X. So from here to here, we're going to call this X, just because this is what we're actually looking for, is this little guy right here. All right, we're trying to figure out how tall our antenna is on top of this building. So find the height of the antenna. Okay, so then if I say call this little side right here, we'll just call it A, doesn't really matter. Okay, then the entire thing from here to here for this big triangle here is X plus A. Okay, if this is X and we just randomly called this A, this triangle here, so the building basically is height A, the antenna is height X, so then for this big triangle, it is X plus A. So then when I go to set it up, I have an adjacent value for both of them, and I have now an opposite value. So setting it up, I know that the tangent of 40, so I'm looking at the small triangle here, is going to be opposite over adjacent. Let me do paper so you guys can actually see this, right? So we're here. We have our building. This one is 40. We're 500 feet away. Then we also have this other one to the top of our cute little antenna. This guy is 43. We've decided the antenna is X. The building is A. And that makes this whole thing X plus A. So for the small triangle, tangent of 40 is opposite, which is A, over the adjacent, which is, 500, because we're 500 feet away. Now, then looking at the big triangle, so let me just draw out the big triangle. So this is the 43 all the way up to, this is building and antenna. Okay, so building and antenna, this side right here is X plus A, so the antenna height plus the building height, but we're still 500 feet away. So that means that the tangent of 43 is equal to opposite over adjacent. So then I can solve easily for A here. We want to find X, so I'm going to solve for A right here. So I've got 500 tangent of 40 is going to be my A value. I'm just going to plug that in there. I'm going to leave it as exact. I could plug that in a calculator and get approximate, but I want my answer to be as exact as possible. Plus 500 tangent of 40 over 500. Solving for X, so I would move that over. So I've got 500 tangent of 43. X plus 500 tangent of 40. Subtract that over, and X would be 500 tangent of 43 minus 500 tangent of 40. Okay, so then from there you toss that into a calculator and you're going to get the height of just the antenna. Okay, I could have solved it differently and found the height of the building first and then figured it out from there, but this is definitely the faster way. It's just to solve for X from there. Okay, but that's kind of the main objective once you get back into this backside as you start looking at that, is how can I take something and take all of this information, which has two separate triangles in it, and create the same thing. So like if I call this A, then this piece right here is X minus A, if the whole entire thing is X. So you get that same general concept, and you start setting up systems of equations that you can then solve. Okay, so set up a system of trig functions, basically, and then go from there. Okay, so that's essentially what you're looking at doing, no matter what it is. Let's see. Okay, so same sort of thing in all of those. And that's all you're really trying to do. Again, give it some kind of thing, even if it's got a value. Give this little piece some kind of name, and then know that the whole thing would be A plus 8, right? So that's one of the big concepts that they're looking at when they're looking at all of these, is kind of setting up that little system and utilizing the exact same variable when possible. So don't call this a B and this an A, because then you get stuck. But if I call this A and I call this whole thing A plus 8, then I can kind of go from there. Okay, I hope that helps with kind of the beginning part of all of this. Do keep in mind that all of these answers are fully worked out on the back there, so if you find yourself getting stuck, look and see what they did, and then kind of go from there.